I basically started watching YouTube videos. Like there are a million YouTube videos that explain you how to build things. So I just bought a bunch of aluminium profiles, bought some tools, had no idea what I was doing, and just built the first like very janky robotic crane system that was able to pick up a brick.
Did you know where to buy your first length of aluminium channel from? Was it an Amazon purchase or was it not?
Part of it was, but for every part that exists or everything that exists, there's a website and you put .nl behind it, the Dutch top-level domain, and you can buy it. So you can.
Why do you take software so seriously?
Because it's driving everything. The last couple of pilots are being like more successful and more successful. We're actually building walls that are still standing outside, and people are actually going to live in houses with walls being built by robots, which is pretty amazing. Yeah, iterate quickly. If we change something, we want to test it same day, basically, at least same week.
So that makes your company super valuable, right? Because your moat is absolutely ginormous compared to just software.
That's what we think too. Yeah, we think we're building a pretty nice company.
Yeah.
Our main focus when we started was general contractors. One thing and they are still like our main customer. We've also discovered that masonry subcontractors, the biggest one, like let's say the top 5, they also want to work with us because their model is they actually also have a huge pool of contractors working for them again.
You a CEO of a tech company or a bricklaying company?
I mean, right now, I'm technically the CEO, I think, of a bricklaying company. Yeah, we are considering that. I think we're basically like at the phase where, so the interesting thing is, and that's part of the things that even drove our Series A was getting the signals from subcontractors and general contractors where some of them were like, starting to see this is real, like the demos here in the office or even on construction sites. And they were asking us literally like, can we get 50 robots booked for 2 years? We have no marketing team at all.
We have a bunch of videos on our website and on.
I knew the answer.
Yeah. I think so. First of all, marketing, whatever, is like we're not marketing ourselves as a robotics company to customers, right? That's actually the key thing. Is again, we tell them we're a subcontractor. We lay the walls. Of course, we talk about the robots. Of course, we show the robots. It's not that we're hiding it, but the key thing is that you are not buying a robot. You're not leasing a robot. You're just getting a wall. All they told us from day one is, show me that this could be real.
Okay guys, episode 3. So in this one we're going to be talking about your roots together and then how you build a robotics company. So hopefully by the end we should have the playbook. Okay, so yeah, it'll be interesting to hear, Sebas, you're obviously Chief Technological Officer here. How did you, we've been speaking earlier, and it's like, how did you go from software to now building these robots?
Good question. So yeah, my background is pretty traditional in software. I have a computer science degree from the university here in the Netherlands, and all of my background has basically been in software, mostly web focused, web products. And together with Salar, we already did a startup called Silk, which is basically a software platform that's very data driven. And my own background is very into software technology, and so it's very meta, very non-applied to real things, but just building software to build better software. But always had a fascination with robotics. Of course, it's a very interesting topic from a technical perspective. And Salar and I think during our time at Palantir already had several dinners where we just started like brainstorming, like we both love hard tech. We talked a lot about biotech, about robotics and that kind of stuff, and so a topic that really intrigued us. At that time, to me, it felt quite like far away from me, like it's not my expertise, so how do you get into it? And after we both quit Palantir, I wanted to do something with robotics, so I started experimenting a little bit, and then Salar had this idea, let's start a construction robotic company, because that's an industry that actually hasn't seen that much innovation. I thought that's a crazy great idea, let's do this. And we basically started diving into it, and I started mostly by just building a virtual robotics environment in software. So just play around with all the technologies, do a lot of reading, think about how robots behave, about kinematics, but also high-level planning. What if you want to control like multiple robots at the same time? How to roam around? How do you plan motions? How do you plan strategies? And started basically building a bricklaying robotic system in software purely without any hardware, and played around with a few months, just playground basically. And I thought this is actually doable, like not thinking about the hardware side at all. And at that point, Salar and I did a lot of like research already into like the industry, into construction, and we decided let's do this, and started basically prototyping our first hardware product. Product is a big word, it's just a prototype. And I basically started watching YouTube videos. Like there are a million YouTube videos that explain you how to build things. So I just bought a bunch of aluminium profiles, bought some tools, had no idea what I was doing, and just built a first like very janky robotic crane system that was able to pick up a brick and to place it somewhere else. So I did some of the electronics, a bit of software. I did most of the mechanics and a bit of the software. And we were just struggling a little, but it actually went quite well. It was super janky. And that's the moment that we both thought, like, if we can do this with the two of us, like in a tiny office, we can probably just find a great team with people who actually know what they're doing and build this into a real version of that prototype. Yeah. And basically, I dropped the hardware part quite quickly. Like once we found the first one or two mechanical engineers, I was happy not to do that anymore. It's not my expertise. It was fun to play around with. I have some intuition for it now, just by running the company, but my expertise is still mostly in software. But I think making simulations in software of hardware and just playing around with it is a good way to like gain better understanding of what's possible. And I think we also went into it quite naively in a sense. You probably know the saying, like, friends don't let friends start hardware companies. We haven't been told that. We didn't have any friends to tell us to do that. Hardware is super difficult. The iteration cycle is completely different from software, so we're learning here on a daily basis, I think.
Nice. Salar, we obviously spoke to you about your background in episode 1. So it'd be interesting to hear how you guys as a team, you more on the CEO background with the more the commercial side, and then you have the technical side. So how do you guys kind of wedge together?
Like back then in the early days, or just now, or?
I suppose, early, and then how you split the roles today.
I mean, I think maybe our team, or maybe you just need this in this at a company like this. Like, I think I'm ultimately not like a commercial CEO, right? Like my own background is also very technical. Like I started, coding as a kid. I'm very technical by nature. I think like an engineer, despite not having an engineering degree. And I'm much stronger on the technical side than commercial. Like I'm not like a sales guy or anything like that. I have learned by now that, for example, I'm very like naturally good at fundraising for whatever reasons. It's just like it's
a useful skill to have.
It's a useful skill to be like if you want to start a startup. It's not like I think in the early days I did think a lot about go-to-market. Like again, because I think it's like very important both on its own, but specifically for this kind of company. It's such a risk to build abstract technology. Like it's very expensive to build robotics that just go nowhere. The cycles are slower. So you really want to know what you're building. You really want to know who you could test with, like get pilot customers or like understand kind of like the use case really well, the business model. And then again, like in the early days, but we were also, I was also involved with like thinking about like what should the hardware be like. We kind of like divide and conquered between us when we were sharing a tiny office that I just got for a while before really kind of committing to the company. And I think, like we never had a very natural, like in a way we work naturally together without a lot of like process. What I would say, which I still think is very interesting, is there was a 2-3 month period during COVID where we actually, some of us couldn't really commute from the city he lives in. We didn't work like closely together physically. And it was like the most unproductive period, I think, of our lives. Like it was very interesting to see how that, like we also need...
Very frustrating.
Yeah, like somehow, despite knowing each other very well, we just didn't become very productive on video calls or Slack, or we really need to be in the same room.
You can't build robots being remote, right?
No, you cannot. But even just like, even the software, like thinking about things, like the whole thing just like struggled to move around that time. And then like coming back again, like a whiteboard, a messy desks, like things moved again. So that was, I think, an interesting observation on.
I remember in the early days, our first whiteboard, we had like a bullet point list of things, the plans we need to do, and like somewhere 6 or 7 was build actual hardware. It was like down the list, like very scared, like, whoa, are we going to do that one day? And then it happened. That was quite interesting. I think we naturally share a little bit of the same vision. I think we both came from the point we want to take a hardware problem and turn it into a software problem. We want to see if we can use smart software to control something complicated. Ideally build many small janky things that work together with smart software instead of building one big perfect product. And that's quite different from casual robotics as you see in assembly lines, for example. And I think we share that vision. If you come from that vision, I think we quickly brainstorm about, we see a fleet of robots roaming construction site working together. And I think I still have that picture in my head, and Salar probably still has that picture in his head, and that kind of drives us forward. Like we don't know exactly what we're going to do. We kind of know what the outcome like looks like on a very vague sci-fi level, and that really works for me at least to have that vision.
Did you start from thinking about code, or start assembling things first, or kind of connect? What was the process? You said the 7 point on the list was to build some hardware, right?
I definitely started with software, just building a simulation environment, just to like get used to the concept of robotics and kinematics. I think still parts of that first prototype are in our code base. It just grew out to what we have right now. And it was also quite elaborate in that it was a multi-robot simulation with like actually supply on site and that kind of stuff, but very basic in some other senses. But we didn't have any hardware. And I think we very quickly in the first couple of months started building something physically.
It is worth saying that I think the biggest kind of like question we both had on our minds is, should we buy a cheap robotic arm to either to practice or to shortcut prototyping, or like that was, I think, maybe the biggest kind of most difficult decision. Is like we kept going back and forth. Like it seemed stupid to build the whole thing on our own. Like I think our initial inclination was we'll build like the platform, the movable platform, some components, and then we're going to buy some arm somehow, because we really didn't want to take on the full challenge. It seemed stupid, and a lot of people told us like, don't do the whole thing.
So the hedge or compromise was, you know what, we start building our own robot, meanwhile still considering if we just drop it and buy an additional arm. So we start doing research. It's just too expensive. It's hard to find the right thing with the right specs. And somehow at some point the thing was sort of good enough. And then we dropped the idea altogether. I think this is the right approach, but it took a while to actually figure out that it is the right approach.
Did you know where to buy your first length of aluminium channel from? Was it an Amazon purchase, or was it not?
Part of it was, but for every part that exists or everything that exists, there's a website, and you put .nl behind it, the Dutch top-level domain, and you can buy it. So you can buy aluminium.nl, that's probably the place you buy it. Buy cheap steel.nl, buy cheap springs, like everything you can buy somewhere.
You do learn about a whole like other side of the supply chain by doing this kind of stuff.
Something you're not used to going into it.
And now the guys have their own list of all the suppliers that work well. They have all kinds of relationships with them, and
Looking at like a broader landscape of robotics companies, maybe in construction or outside of construction, is what you are building here, is it unique in any way, or is it similar model to other robotic companies, not necessarily in construction? How do you see that?
I would say, I think the way I think about it is, I think in philosophy, let's say, like in the way of thinking, we're closest to, I'd call them autonomy companies. So the companies that put machine vision, machine learning, software first in their model, and then still build their own hardware. So there's like self-driving car companies are like the oldest or the best example of that. There are like smaller autonomy companies, the ones that do like these tiny like, wagons, AGVs that deliver pizzas, or maybe in a hospital. Like there are all these different use cases. There are some companies in construction that are not doing what we're doing, but like I think there's a company called Build Robotics in the US. They retrofit, big ground preparation machines like excavators, etc. But they use like machine vision and autonomy software. I think that the mindset, I would say, roughly is closest to them than, say, a company like ABB or KUKA or Fanuc that creates like these, industrial robotic arms that you'd find in like a car factory. We're not really like them. We don't build the hardware like them. They don't take software as seriously as we do, right? So that's also like the contrast.
Why do you take software so seriously?
Because it's driving everything. It's basically, we come from a software background. I think that's key to it. But I think one of the examples is, if you look at the other companies, one benchmark that you can take is you can probably not hire that many people from a company like ABB to start working here. It's a completely different mindset. They use these big industrial controllers, and they program it with this very complicated control software that is very like proprietary and like very well tailored to do everything very specifically. And we use off-the-shelf available like many open source software, hack together some stuff just to make it move around. So it's more like the hacker scene and like the builder scene that you see on YouTube applied to a slightly more serious project. And we can just hire basically normal software engineers that are just willing to learn quickly a slightly different domain, and they can just dive into this and work with this. And we have a very large like centralized control platform in software that deals with multiple robots, as fleet management, can do individual motions of robots, but also let them work together. And we can very quickly iterate on it. We can come up with a new strategy and like roll it out the same day, start testing it with, just script around. Completely different mindset from classical robotics, where you have these very complicated control structures that are being deployed on a like weekly basis, maybe to test tiny updates. Yeah, it's just a different world.
Yeah, so in the first episode, we spoke quite deeply about the business model. But what I'm interested to sort of also hear from Sebas is the speed of iteration. So you mentioned about not being stuck in like an R&D mode and actually going out and getting the brick walls built. I guess that is a unique thing about how you guys approach it. So could you...
Yeah, I think one of the first discussions I had with Salar when we started the company was this time, because we didn't do it for like the software, let's try to make money as soon as possible, just make revenue, because it's the only way to validate your progress, and just didn't feel like fun to like build something and then just keep in this loop and iterating, making it better, but you don't know for what. Mm-hmm. So we wanted to build something as soon as possible and move it out to the construction site.
Your investor loved this idea.
Yeah, of course. And we did it. And it was a huge, painful experience, because we went on site with something that just wasn't capable of doing what we wanted to do. And we're also naive about it. Like, we didn't really realize it wasn't good enough. Like, we thought, well, maybe we pull it off. And that's part of the deal. That's like, if it was perfect the first run, we probably did something wrong. Like, we spent too much time. We should have gone outside earlier. So yeah, we just make updates. We go on site and we just try to build something. And if we fail, we feel bad about it. But it's a good lesson, and we do it again. And last couple of pilots are being like more successful and more successful. We're actually building walls that are still standing outside, and people are actually going to live in houses with walls being built by robots, which is pretty amazing. Yeah, iterate quickly. If we change something, we want to test it same day, basically, at least same week. That's very essential.
Let me add one more tiny thing here, which I think is just like also impossible. It's not just about the speed of revenue, or like, I think it's impossible to properly scope the problem, even if you spend a lot of time on construction sites, write down everything. Like, the kind of problems we've encountered are everything from like weird pieces of rebar sticking out and blocking a robot arm, to like the way sunlight reflects on a specific type of insulation material that is used as a backdrop. Like, how can you even like come up with all the problems you will encounter? But these are the types of problems we've had to like think about, as an example. There's no other way to like go through that learning, I think.
And we briefly touched on this in the previous episode with Stijn, where even we see part of like going on site and logistical processes and operations, and how many people we bring and how we set up robots is part of our product. And there's no testing it here, like it's already standing here. So if we want to build a wall here, that's easy, right?
Nice, dry, clean.
Nice, dry, clean environment. We need to go to the rugged terrain. And every project we do, we learn new stuff, and we need to keep doing that. Otherwise, you get nowhere.
So how much of your current success you think is the fact that none of you have construction background? Because I think there is something to it, that probably people within construction industry, they are slightly biased towards some solutions, and they would say that, oh, we can't do that because X, Y, Z. Whereas if you don't know what the problem is, you kind of go and try to find a solution for it. Yeah?
You need to be a naive outsider to some degree, right?
Yeah,
like, I think that's actually a common thread with a lot of companies. I think people who are really in the construction industry and also might have like the skill set to start a company like this, I think because they understand the full depth of the problem, they're also like, you can't even start this, right? So you need to be a bit naive.
That's fascinating to me.
Yeah. So
it is interesting though to see how I'm impressed by the construction industry itself, like how resourceful they are. Like, if they go to a project and they basically plan almost nothing ahead from on a detail basis, and everything goes wrong all the time, and they find all kinds of solutions to work around it. And that's really fascinating to me, and it's also something we're trying to embrace. So if you go on site and it doesn't really work out, and like a piece of rebar sticking out, and we cannot work with that, we don't go home. We try to find a solution. Like, we need to have the same mindset as construction. Like, stuff will go wrong all the time. It's your job to work around it and make sure the end result is good. And that's part of like company culture that you just need to embrace. And I think construction industry is actually quite good at that.
Yeah, I think there's a term in like human psychology called beginner's mindset. That's where you just kind of, like, your mind is so like virgin to everything that's going on, is very moldable, and you can almost uncover things by accident, like, oh, I didn't realize that we could do it this way. When you're too fixated, you just
And you need to
down
keep
the
that
same-
right over time. Like it's very hard for a startup to keep that mentality going over the years. You still need it all the time. You need to have some naivety to dive into problems that look too complicated to begin with. And once you get better at these things, maybe some problems become harder or look harder because they fall outside of your comfort zone. So you need to remain that mindset somehow.
Yeah. What was your first hire? Who was your first hire?
The first hire, actually, we hired two mechatronics engineers as almost like as contractors initially, just to like try it out. The first real hire we made actually was like our only non-engineer, because I knew from previous experience that that's something one we would need immediately. So that's Lottie, our head of operations. In a way, she enabled it, like the first phase of the company to be able to focus on like building and doing the R&D part. But we focused on the hardware team first, both knowing that the hardware cycle, like we knew least about hardware. So like basically we felt like we could augment the lack of software engineers initially. And the bet that hardware is also, even with our approach, is going to be slower. And so it will take some time before the hardware would catch up to like where we were with mostly with software, what Sebas made on the software side.
The first hire was like mechatronics mechanical engineer who has just a wild general experience with doing everything, 3D printing, working with aluminum, working with mechanism, that kind of stuff, which was like
Like an alien to us.
jaw-dropping for us. Like, oh, you have so much knowledge that we don't have. Like,
Yeah.
let's do this. Yeah.
Yeah.
Just wanted to ask about, so Pisa 4, the one behind us. What like product iteration is it at right now?
So the 4 in PISA means it's the 4th one. It's not the 4th generation. So we have 4 of these systems now, or this is the 4th system at least. I think this is it's hard to talk about iterations because we have iterations on the cranes themselves, on the robotic arms basically, and we have iterations on the wagons. And this is like, but this combination is the first viable robot that builds proper walls on site. We have had 2 iterations before. With a different type of wagon, a different type of crane system, slightly different arms.
You think about iterations in components?
More in the component layer than on the system layer.
On the whole, like a robot, yeah?
Yeah. But these cranes, for example, we call them the C4s. So that's the 4th generation of crane system and spine system. We started with a robotic arm that didn't have the elbow joint, so it was just sticking out like this. And that was a very interesting design to test stuff, but you have no reachability, like you cannot pull it in. So we couldn't work with a backdrop at all. We could only work on like a freestanding environment. So we need to put the elbow joint in to work in different setups, which is a thing we did I think in 2 weeks. We went to a pilot and they promised us there was no backdrop, so we didn't need to have the bend in the arm. And then we went there scoping and there was a backdrop. And then we had to change the design. Like speed of iteration, that was amazing. Like in 2 weeks we managed to completely redo the arm design in order to pull off that wall build.
But like the end effectors, for example, I don't even know. I think we're like
20 or something.
Yeah, it's like some parts just like move so quickly. Like we just like keep iterating on them. The hopper, like the thing where the mortar comes out of, like we've tried so many things there. But that's the nice thing. You can actually iterate really quickly on like subcomponents on a more than weekly basis in some cases.
Yeah. So how do you do that? Because we saw earlier, we were walking around, you see you have a lot of facility on site here, like 3D printers, like a whole almost hardware shop. So like, was that always part of the plan to like help with the speed of iteration? Or is it something that you, like, how did you learn that was the...
Yeah, having a prototyping workshop in-house is very important. I think we couldn't have been doing this without. Nowadays, like we have some kind of a settled design, so we can order a lot of stuff and just assemble it here only. But the previous versions were actually all built in-house with our own 3D printers, CNC machines. And yeah, I think the 3D printers, we have 8 of them now, I think they're running continuously, like all the time. And for example, the entire mortar hopper is a 3D print. So if we make 2 spare parts, these things are just running all the time. But we are ordering like pre-made stuff more nowadays. For example, the wagons are just folded boxes of sheet metal. So they're laser cut and folded, and that's something you can just draw up in your CAD programs. You can order it and it will ship the parts to you. So we don't need to make these things in-house. But for prototyping reasons, yeah, workshop is very essential.
Yeah. And how many times, like, do you ever go down a rabbit hole of like focusing on subsystems too much?
Sometimes, like, yeah, it's always a question,
How
right?
do you know you should get out of the rabbit hole, perhaps?
I think it's one of the most complicated questions is, are you going to redo a design because you think it can be better, or are you going to improve the current design because you are time and resource limited and you need to get something working? I don't have
any metrics, or how do you measure it? Like, where should I go?
It's a little bit of metrics. It's also mostly gut feeling. Like, I think it's very hard. It's something that's going to be maybe even harder once we now have 4 to 6 systems. Maybe if we have 20 of them, like, it's pretty hard to retrofit all of them to do something new. So are you then going to build a new system that has some upgrades, or going to like retrofit them on the old systems? Or when are you going to do that? Or going to send some out with the old version that is slightly worse maybe, but good enough for some projects? I don't think that's an easy question to answer. We're dealing with these questions every day. It's the struggle of a hardware company, I guess. Software is easy, right? You just deploy new versions everywhere. It doesn't work with hardware.
Yeah. How do you get feedback? Do you get team around, or you two of you discuss and then make a decision based on like financials, or how much things will cost to redesign or rebuild? I know it's a tough question.
Yeah, it's a bit of everything. So first of all, just use the system, right? We do wall builds every day in here, and we try to do as many projects on construction side, and we just keep track of everything. I think we discussed that before. We keep friction logs, like we say. We log everything that's happening, everything goes wrong, but also things that are successful. And we combine that with extra metrics that come from the system. So we track brick quality, if we place a brick, if it's placed correctly or not. We correlate with the type of machine, with the parts that are on the machine, and that way we can actually make quite good guess on what needs to be done. For example, if we redo a gripper with a new version, but then we see that all the bricks are slightly rotated in a specific way, we might correlate that with the new version, and we know we need to redo it. But most of it is just observation, like we do wall builds and we're looking at it every time. We have some great engineers who are just trying and testing and write down everything, and then like on a weekly basis you go over all the issues, you write them down, make product decision based on that.
Yeah, so talking of that though, I mentioned about the workshop and the 3D printers, which nicely feeds the iteration. What Salar, you're also convicted on is physical proximity of your team. So here being on site, you have guys working on bricks, you obviously have the robots here, you have the software team up in the office down there, the hardware shop underneath. Like, explain that philosophy.
I think you just need this density. I've heard this in some, like I've heard different variations of this as well in other companies, but like I think everything is like a very tight loop right now. So for example, we're not at the phase yet where we could be like, we're manufacturing. I mean, we are manufacturing. We're like the fact that we have like PISA 4 is like, it's number 4. We're building like the batch of 10 right now. But it's not a state where it's like the design is set in stone, everything is properly documented. Let's hand it over to this, manufacturing team. It'll just like go on some production line and build it. And so there are like all these feedback loops of they're making something, tool access is bad. Like actually, it's really hard to make this part. Like it's properly designed from maybe a product perspective, but not from a manufacturing perspective. Big companies will have all these processes around like design for manufacturing, design for assembly. We think about those things, but we can't like become completely process heavy, right? So the way to do this is you just have everyone in the same space, and then they can just like pull each other in, check in on each other, ask questions. And that's like through osmosis, you just like pick up so much more, right? Like the bandwidth of just like being physically in a place is so different from like the bandwidth of just communicating over like meeting notes or like emails or whatever other. And that's true for every so that's true for manufacturing, but also like building the walls here. Like almost on any day, even if I'm super busy, I'll just like walk around, just look at the wall, and you see things are going like terrible or great, right? And you can kind of get a gut check of like we're on the right track or not. And I think there are like many layers to this, and I don't know how to replicate that in a if you don't keep everything tight to each other.
And one example is, of course, something to think about. We have a hardware team, we have a software team, and sometimes something doesn't work out. You build a robot, you manufacture it, and it's a little bit more shaky than the other robot before. Yeah, how are you going to fix it? Like, are you going to say, hardware team, go fix this issue, make it stiffer, make sure the bolts are properly tight, or redesign it? Or are you going to go to the software team and say, can you write some complicated control software that actually works around this limitation so we can still build proper walls with it? Both are valid answers. Like it depends on like what the software team is doing right now, if it's more important or not, or what the hardware team is doing right now, or if they come together and are both in proximity, maybe they can do a little bit of both. So maybe there's a very cheap solution that makes it slightly stiffer in an easy way, but doesn't take much time, and you have a very simple routine to work around that with software. Maybe that combination could be like 10 times as quick as like one of the better solutions they can do on both sides. So they need to work together. This proximity is important, and otherwise you just get these much longer iteration cycles where people try to make things perfect, take too much time, and maybe it's not worth it in that case.
Do you follow some sort of like product development methodology, like team sprints, and how often do the team get together and like discuss the software and the hardware integration?
One room actually, right? Over there. It's one room actually, so software people.
It's one room, yeah. We try to use as little process as possible. Of course, we have like ticketing systems and like we do projects in our Notion pages and that kind of stuff. The usual that you can, but we are not very process heavy. There are lots of meetings. We try to keep them small to make sure that, but yeah, there needs to be discussion, and lots of stuff happens informally, right? When people just are working in a team of two, and you try to be interdisciplinary, and then stuff comes out, write it down, talk about it next week in an engineering meeting, and then continue. But yeah, as process little as possible, and proximity helps.
Yeah. So in terms of process, like we have one weekly kickoff meeting, basically. Which is basically our main agenda. And we explicitly keep hardware and software together because that's kind of like the main interface for the kind of conversations that Sebastian mentioned, where a lot of things, it's not even obvious if you should fix them in hardware and software.
Yeah, I really liked it when I was in the other room. You have mezzanine where there's people working on the probably software, right? And down there, there's 3 robots doing
It's a very, very good setup, yeah.
It's a great setup.
Yeah, how does geography, this last one on the sort of talent question, but like how does geography affect what you're doing? Because Salar, you're obviously used to building in like San Francisco in the Valley, and you know there's like the pool of talent you can get over there. Does being in Amsterdam restrict you, or do you actually find that here there is a lot of great engineers?
I think it's a really good question. So Amsterdam or the Netherlands has, I think, a great software ecosystem. There are like great software engineers here. There's also, for example, great graphic design or visual design talent. That we don't need that, but like there are like some pockets of talent that are actually exceptionally good. I would say on par to the Bay Area in terms of software engineering skills, for example. The difference I would mention is like experience in like a fast-growing startup is lacking here, right? There aren't that many fast-growing startups, so not a lot of people have experienced that. There are also big advantages, right? Like you are competing with less companies there. Loyalty is much higher here. Like retaining good employees is much easier in Amsterdam versus like the Bay Area,
That's
even as a great company. What is more of a challenge, I think in general, but I think Amsterdam doesn't help, is hardware engineering. Unfortunately, like many places in Europe, like we lost a lot of like kind of hardware, like the kind of culture of like hardware companies, mechanical engineering, electrical engineering. The ecosystem is not huge. There's some in the Eindhoven area, which is where ASML is based, and some other like tech companies. So, but what works well, I'd say, for Amsterdam is like it's really easy to relocate people. It's a very kind of like nice, livable, cosmopolitan city with a reasonable cost of living compared to say like London or US cities. So we've actually also relied on just like finding talent from all across Europe or the world and just getting them here when we need to.
Yeah, and I would add, especially the combination of hardware people who are really into the startup idea.
Yeah.
Like that is just a very difficult combination to get. There are more traditional like hardware, mechanical engineer jobs. Like if you go into energy sector or like big companies like ASML or something that exist. But the hardware, the startup vibe is kind of missing there, and hopefully we can be a bit of energy there.
Yeah.
What are the most significant challenges that Monumental faces, and how are you addressing them, if there are any?
And maybe some from the past as well, like where there are times where you were like, damn this.
I mean, our biggest challenge, like from a product perspective so far has been, and I think we only sort of recently solved this, is can we actually build a high quality wall using robotics? Like that is, and on site as well, like where the situation is very unpredictable. And I think we can now safely answer yes, but that was not that clear like half a year ago or something. Like we're almost there, but you never really know, right? Are you stuck in this like local optimum where you start iterating and it doesn't really get out, or can you still like apply some small fix and get there, or do we need to redo the entire design and just come up with something completely different? And that was not a very easy question to answer, and I think we now have the answer, and the answer is yes. It could still be better. Like there are some upgrades we can think of that make life easier, but I think actually getting high quality walls that are being accepted by the contractors is the end goal, of course. And I think the answer now is yes, we can do that. And that wasn't always clear.
Maybe what parameters are you looking at in terms of like plumb line or the depth of the joints, or what other parameters are you looking at? And perhaps if you can say which one of those are the most difficult to factor into.
In the end, it's very much an aesthetics thing. The masonry walls, like the facades that we're building, especially in the Netherlands, but I think most over the world right nowadays, are not structural. So you're actually looking at something that's made for aesthetic reasons. And general contractors just walk by, or even masonry subcontractors, we're working with them, and they just point at it and say, this looks ugly. Yeah, it's basically a very aesthetic thing. Of course, they need to be straight. They kind of fall over. These are relatively easy for us to achieve, but just making sure it looks consistent on the eye. You don't have, like, if the bricks roll a little bit in a certain direction, you look at it and the sun goes up, you can see the shadow lines, it becomes messy, it doesn't look great. Or maybe you have mortar stains because you have a little bit too much mortar, and it doesn't look nice. And they will say, it doesn't look nice, start over. And there are not very specific measurement, it's not how masons work, like constraints or something. It's very aesthetic, but you will see it. You can see, oh, this one sticks out. So getting a nice, consistent wall over a long distance, that is a very big challenge, and you immediately see it.
Well, we can quantify it to some degree, because the way we think about it internally is, in robotics, people talk about a pose. A pose is like 6 dimensions. Like you have 3 dimensions of like a position, just like a position in space. And then there's like 3 dimensions of rotation. So if you think about a brick, it needs to be somewhere, like the middle point needs to be in the right place. There's a perfect place for it. And then it can be rotated in like some way, and there's like obviously, we think about the pose of the entire wall, sections of the wall, and then each individual brick. And we try to actually measure that and analyze that. And then what remains is like the joints. That's both like the distance, but also how, as Sebastian says, like how clean they are and how filled up they are. You don't want to under or over extrude. There's like a Goldilocks kind of like zone of like doing it right, and then not staining the bricks. Those are like roughly the main kind of criteria of quality. And it's worth understanding that, for example, rotation is like actually quite hard to like basically have 0 degrees of rotation. What is an acceptable amount is like that, it's something that shows very quickly, like if something is sticking out, a point is sticking out, much more than other like faults. And I think that's like something where we spent a lot of time thinking about, both on how to fix it and how to measure it.
And to get technical, we get now to like 0.1 or 0.05 degrees of rotation that we want to get out, because that's a little. It's a little, but there might be some of that in the system, and you will just see it. It becomes more messy. So we're actually, trying really hard to get it right.
So can you achieve this through hardware, or it's a software issue, quote-unquote issue more?
It's everything. It's a very, very big pipeline to get it right, and it starts all with like the robot needs to localize itself based on the marker, so we know exactly where it is. Then we need to know exactly how big the robot is and how the joints are positioned at that point. So if it's a little bit of stretch in there, you need to know exactly. Then you need to translate these factors. You need to calculate exactly where you are in space. Then you need to know exactly that the brick is positioned correctly, what the shape of the brick is, how it's being picked up. If the robot is not leaning over a little bit, all these factors need to go into play to know where the brick's being put down. And so if it's wrong, it's also very hard to tell where it comes from. So we have all kinds of debugging tools to actually do deep dives in. Is it a localization issue? Is it a mechanical issue? Is it a software issue? Is it a computer vision issue? Is it a compensation that we try to apply kind of issue? Is it specific to this robot, or do all robots have the same, like inhibit the same kind of issue? Yeah, it's very difficult. And it's a combination of everything. And
just to keep, so that's actually like, that's the main, I think, like accomplishment or technical challenge where like, if you think about every step in this pipeline that Sebastian is describing, you add it all up together, and then you end up with sub-millimeter errors, sub 0.1 degree rotations. Like that is actually exceptional. Like that is, I think, like even like localization, for example, like self-driving car companies, which have way more resources and have been doing this for a decade, they actually aim for centimeter level accuracy, right? Because that's what you need on a public road, for example. But that's not acceptable in construction. So like you need to do better than that.
Yeah, talking just on this subject of challenges, does like rapid technological advancement not threaten, but like, is it something that you guys need to consider as much as say like a traditional startup software company? Like AI obviously is big hype right now, and ChatGPT, whatever the tool you use, you can go in and get like pretty decent code output out of it. So is that the same with you? Because what you're building is obviously very unique.
I don't see it, but if it's there, I want to have it. Yeah, show us. No, I think it's such a big pipeline that we need to get right. It's such a like day-to-day engineering challenge that I don't think you can just throw AI at it or something else and get better. Obviously, we're making use of some AI tools for computer vision purposes, but also we use it in our coding workflow. We use a little bit of all of this, but it's not solving the problems. There are tiny tools that we can apply. But maybe at some point we can do a little bit more. If we have very complicated building patterns and we need to figure out how can the arms behave without colliding. Now we need to do all kinds of complicated control software. Maybe we can use some AI models to like find the best path, that kind of stuff. I can see how that works. I don't think anyone can just say, oh, here's a humanoid robot and some reinforcement learning and a proper wall will arrive. I don't fear this at all. And if it's the case, that will be amazing, right?
So that makes your company super valuable, right? Because your moat is absolutely ginormous compared to just software.
That's
so,
what we
yeah.
think too. Yeah, I think we're building a pretty nice company.
Yeah.
Good. I want to touch on, so Patrick Kellerman, who is investor from Fundamental, he mentioned that every time you innovate, you disassemble and reassemble the robot. Mentioned something like that?
I mean, I think it's more like because we work in a modular way, we don't like, it's not like any tiny modification. I'm actually not sure about that, but like I think that the point is that we iterate on modules. And so, for example, if we have a new, like we have one robot right now kind of assigned for hardware prototyping. And so like engineers can come up with new like end effectors, they assign it, but that doesn't mean they don't need to think about the wagon or if it turns out that what they're doing works, we retrofit all the other robots. We take apart those, take away those parts and attach them to them. And that's how we can kind of, that's why it's hard also to keep track of what generation a robot is, because we keep changing like sub parts of it, but I don't even know what part is like constant of a robot.
The ship of Theseus, where if you take everything apart and like one by one replace the items, is it still the same thing? It's hard to tell. Like we know we have in software what the history is, but it's hard to tell what it actually means, right? It's kind of nice because if this crane system is outdated or breaks off, we can just take it off. This wagon can perfectly be retrofitted to be a brick supply, and it's just modular in that sense. And
how many components does it have? Like there's 1, 2, 3 main, like the wagon, then the tower, the arm, and this is like main three components?
We think about the mounting points, right? What are the modular points where you can mount new stuff on it? And the wagons are the same. We see the leveling system as a unit that we put on some of the wagons, but not all of them, so we can easily take them off or put them on if we want to. Then the cranes are obviously 2 specific cranes that go on there. We see the spine as a single thing that can rotate and has a lift module. Then the arm, basically the the upper arm and the lower arm are unit. We made several versions of them, and you can just take them off and put a new one on. And then obviously the end effector that's mounted underneath. And this is the mortar hopper. You can take it off, you can put a new one on, it will just behave the same. On the other side you have the gripper, which also mounts on an extension to make it be able to work on the ground, and that extension you can also pull it off and you can put it out without an extension, so you can work higher up. These are all like mount points, and you call these components 1, 2, 3, 4, 5, 6, 7, or yeah.
So we spoke about like bricks and like laying bricks, but what about what else goes into brick, like mortar joints, things like that? How do you, obviously there's lots of different mortar joints you can do, and also they need to look good and work. How do you approach like the different types? Do you focus on one that is perhaps more common across the Netherlands, perhaps?
Yes, so the most common like bond, like you said, like the pattern that you see in bricklaying is, I think it's a stretcher bond, where you just have bricks alternating. It's like if you ask a kid to draw a brick wall, they will draw this pattern, basically. And that has the horizontal joints, we call them bed joints, and then the vertical joints, you call them head joints. And that is a very simple pattern, and we're focusing on that. We're doing some other patterns as well nowadays, but that's the focus has been on that. And once you nail that, the other patterns are just variations of it. So you have a slightly different software model for this, but motions are more or less the same. And then we use the mortar hopper to actually put the mortar in between, and that's a very delicate process. Mortar is a very weird substance. It's not really a solid, it's not really liquid, it's somewhere in between. And we use mostly vibration to get it under control. So we vibrate the mortar so it becomes more liquid. And so we have a way to control how much comes out of our extruder. And we also use active control loops to actually vibrate more and less to make sure the exact right amount comes out. And do all kinds of intricate motions to lay the bed, and then go sort of an L motion to go up again to do the head joint, and then push in the brick. And yeah, that is very, very tricky. We try to stick with the same mortar that's being used on site, so we don't use any additives or anything. It's just the plain old bricklaying mortar that they use on most construction sites. Yeah, and it's quite difficult. It behaves differently in different temperatures, different water consistencies. So we try to measure how much it is, and we base our extrusion on that.
Let's talk about a little bit customers that you work with and the feedback that you get from them. Who do you work with as a type of the customer?
Our main focus when we started was general contractors. One thing and they are still like our main customer. We've also discovered that masonry subcontractors, the biggest one, like let's say the top 5, they also want to work with us because their model is they actually also have a huge pool of contractors working for them again. So for them, plugging us in as like another kind of like source of labor in a way makes a lot of sense. So today we're working with the biggest masonry subcontractors and general contractors directly, depending on the project. They are our customers.
It's a very interesting model, like this outcome as a service. You a CEO of a tech company or a bricklaying company?
I mean, right now, I'm technically the CEO, I think, of a bricklaying company. That's like the revenue we get is revenue for laying brick walls. The product we sell is a brick wall that we deliver on a construction site. So if you'd look at it, like that's ultimately what a company is, that is what we are.
It allows us to cheat, right? If something goes wrong, we can do a few bricks by hand if it's in a complicated corner and then continue again. As long as we are efficient enough to make that economically viable, like we can pull every trick out of the book just to make sure we deliver walls in a proper way.
Yeah. Well, did you consider like I think you touched on it in the previous episode, like the larger real estate developers, and they weren't quite your target customer. Is that right?
Yeah. So the problem with real estate. So when we started, and even at some other points, like we have a lot of interest from real estate developers. They really want to kind of talk to us or help us. Or the problem we found is, and their motivation is in a way they are more economically aligned with us, in the sense that they are really looking to lower their construction costs, speed up construction timelines, right? Like they actually feel the pain more than the general contractor. The general contractor basically is executing and they just like pass on the cost and the timeline to their customers. And because it's not a highly competitive landscape, like in a way everyone's doing the same things, I don't want to say they don't care, but the pressure is not there. So we feel like a high level of alignment with real estate developers. But what we've also found is that they're unable to affect the change or like get us in an effective way, right? Because they don't micromanage their general contractor. It's a bit weird if you're like real estate developer tells you, go build this whole thing. I don't care about anything but use this bricklaying method or like technology or company, right? That's kind of unusual. In some cases also it changes the liability because a general contractor is liable basically for all. Part of the point of being a general contractor is like you pick your subcontractors based on that's part of the skill set, and then you take on the liability of everything that goes wrong. That is actually part of the whole like value prop of a GC to their customer. If you come in and you tell your GC, I want you to use that subcontractor, they will typically say, sure, if you want to, but any problem with the subcontractor is your problem. I didn't pick them. And no one wants to take that on. So in reality, it doesn't work. So we still like try to align with them. We want them to kind of like be excited if we come in a project where they're involved, but they're not our customer.
Yeah. How long did it take you to sort of figure that general contractors were the one versus like the developers? Did you like, I suppose in the early days, like you mentioned, commercialization was important, so you were constantly thinking of revenue. So you must have got some immediate feedback when you went out to the market, or did you just kind of hit it on the head and it was like, yeah, we know these.
I think we knew quite quickly, but I would say like as far as there was any confusion or delay in like figuring out the right conclusion, it was because there's real interest. Like real estate developers are really interested in what we're doing. Like even today, they still reach out to us. They still want to talk. They want to figure out how to get us in.
To show off what they're working on, and
yeah, because again, they actually feel the pain that we're solving in a way that's maybe even more like tangible to them than to the contractor. But we just, at our scale, at the current state, it doesn't make, like, we can't really plug into anything they do. And so that just makes them a non-natural customer for us.
Yeah. How did the first sale feel?
Pretty good.
It's pretty amazing how contractors seem to be open to these things. Like, we didn't expect this when we began. We really thought this is going to be very hard to get the construction world on our sites, and they seem to be all very open, very friendly people. They can't innovate themselves. They're just tied with their hands behind their back because it's just not the world that you can do this. They don't have the investment to do it. So they're very happy to get us involved as long, like we told you, as long as the risk is low for them. They're very open to this. And it's pretty amazing.
Yeah, would you consider with them like a partnership agreements as opposed to like, at the moment you're being treated as a subcontractor, I'm assuming project by project, but would it not make sense for you to like go into like some kind of strategic alliance with them?
Yep. Yeah, we are considering that. I think we're basically like at the phase where, so the interesting thing is, and that's part of the things that even drove our Series A, was getting the signals from subcontractors and general contractors, where some of them were like, starting to see this is real, like the demos here in the office or even on construction sites. And they were asking us literally like, can we get 50 robots booked for 2 years? Can I get exclusive capacity to 50 robots? And they were like, hold on, like we are definitely not there yet for many reasons. There's that's definitely where we're going to trend, I think, in many ways. And we just need to also make sure we have the skill to like deliver.
50 robots. So what can 50 robots do? Or maybe 5, let's say 5. What 5 robots can do like in a day, for example?
So now if we have a good day, a single robot can go up to like 500 bricks a day if we're lucky. So if you put like 10 of them at a construction site, you get to like 5,000 bricks a day. I think currently a mason is around 600 to 700 bricks a day. So we're not up to speed with that, but like yeah, at some point we're close to it. So it takes some iteration, but we're close to replacing like a single mason with a single robot system. And our advantage, of course, you can deploy multiple robots at the same time, have them work longer hours.
So if there's like a single house with 2-story house, let's say 10 meter, 10 meter, 10 meter, 10 meter, how many robots will work? Was it just 1 or 4? Or
ideally, you put a system, like 3 of them, like the crane system and then a supply system and the refill system on a single site, for example. So you start doing all sites and you just work together. If you have more available, you can also, of course, put multiple robots on the same, but then you get into clashes where they reach each other and then maybe you slow down yourself a little bit again.
So ideal model is 1 robot per house in this case?
Yeah, or maybe per 10 meters or so, yeah.
Per 10 meters.
Yeah.
Okay. We have to figure this out, but it's also like, it depends on the pacing of the site. You probably know this, right? But like if you have a development, for example, like moving too fast actually doesn't accrue any advantages, right? Because there's kind of like a sequencing into it. So
just give us more robots.
Yeah, so like the thinking is basically that the answer could be anything within like limits, which is like, it can be 1 system, but we can scale up 2 to 4 or 8 systems on a single like project, like house, or like if we need to go much faster and if it makes sense for the project.
Yeah, I'm interested how you market a robotics company. Do you have a big swanky marketing team?
We have no marketing team at all.
We have a bunch of videos on our website and on.
I knew the answer.
Yeah. I think so. First of all, marketing, whatever is like, we're not marketing ourselves as a robotics company to customers, right? That's actually the key thing. Is again, we tell them we're a subcontractor. We lay the walls. Of course, we talk about the robots. Of course, we show the robots. It's not that we're hiding it. But the key thing is that you are not buying a robot. You're not leasing a robot. You're just getting a wall. That's, I think, really, really important. What we found from day one, like from, I think even before incorporating the company, is almost everyone, I would say, is really, really interested in this. They understand that this is a problem. They know the demographics. They know all the challenges. Like, we don't need to explain the problem to the customers. All they told us from day one is, show me that this could be real.
Yes.
Show us. Like, they've been burnt. People have been hearing about robots, doing these things from like the 60s or 70s, right? So in a way, people are just like jaded. Like, yeah, we've heard this story before. It never works for so many reasons. And so like for us, selling is actually just getting people into the space, especially in the early days before we had any like real projects and pilots going on, and that they would see how we were approaching things, the walls we were building, the iteration cycles. And I think either the first, but mostly the second visit, when they saw also how quickly like things changed between like in a 3 or 4 month period. That's when we started to see like people getting like this could be real.
We've had so many contractors coming here for a demo, and then they said we've been hearing about robots like for the last decades, and everyone's talking about it. It's the first time I see it, and it actually works. And it's very amazing to hear that they actually say this is the first one that actually builds a wall.
It's quite funny because like the biggest robotic companies in the world, and there's a particular one who are like more about, not more, but like let's just say like the marketing budget is probably astronomical because the robots look great and are like interesting to humans, but perhaps the outcome, i.e. the business, is a little bit.
Yeah, I mean, this is also a pet peeve of us, also not just like for these kinds of companies, but like I think if you look specifically, there's something about bricklaying. Like it's one of the things that actually, like people have been trying to like automate bricklaying since like early 20th century. Like that's actually kind of fascinating.
It seems so simple, right?
It's mechanical machines, right? Like not robots, of course, but just machines that. And
one of the things that's like there are all these like I think if you just look on YouTube or Google or just like for bricklaying robots, like I feel like every robotics university department is like we've solved like robotics bricklaying. And there's like one expensive robotic arm, just like. It's stacking bricks or blocks. There's not even mortar involved. There's
very intricate patterns, very natural,
it's
very
like
beautiful.
We've nailed it, and that's kind of like the academic approach, which does not incorporate any of the actual challenges you'll find.
On-site constraints, etc.
That you'll find like on a construction site.
So, what makes you think that Monumental will be successful 10 years from now and will not be like other companies which try to make bricklaying automatic 10, 15 years ago?
I think fundamentally the sort of, let's call it humility of wanting to stay very, very close to the market and getting these feedback loops that are not, you can't hack inside. It's like, oh, we achieved some internal metric, that means we've succeeded, which is like how you, but it's like, we just go on site and the customer says, great, well, here's the money. That's like and just like keep doing that, right? And the fact that we've already like had a few cases where we thought we initially did a good job, and then like initially we never thought about mortar staining. We just looked at the brick positioning. And then the first customer's like, these bricks are stained, that's not acceptable. And it kind of makes sense. It's like you feel stupid once you hear it. It's like, how could we have never thought about this? But you're
just horrible.
You're so focused on like some aspect of the problem that you kind of forget about the thing you're doing. And it's really, and I think just like having that kind of like staying close to the market is the way we will succeed.
And I think from a like technical product perspective, the reason, the way to achieve this is to have a very flexible platform. So we're not going to build something that's super highly tailored to a specific use case, because that makes it very hard to get close to the market and keeping up with like what's going on. So yeah, we're trying to build something that is like very tailored to bricklaying, but still very generic. So we can iterate quickly. We can do all kinds of other tasks, like we want to do site logistics and make sure we can do automatic providing of bricks and maybe automatically scraping, that kind of things. And that just requires you to build a very generic product in a sense. And I think we're doing that. We have a very specific way of thinking how we build these tools, and that will allow us to do all kinds of different types of projects and stay close to the market.
Are you talking about bricklaying or outside of bricklaying as well?
We're starting with bricklaying now, but there's nothing that prevents this machine from doing something else, right? We can also maybe install insulation material, or maybe we could do the door frames or the window sills and that kind of stuff. There's nothing. Maybe we need to make some variations to the hardware, make it slightly stronger.
The software component will be there, right?
The software component will be there. We need to build something on top of it, but the platform will be there, and we can leverage everything that we're doing so far. And that's why we think we can go into different verticals related to this and maybe take away more of the outside wall building.
Seems like a multi-decade bet.
That's what we're hoping for. I think we're both motivated that this is the kind of company where if things go well, we won't get bored, even though we're like founders who are not like, we're not operational machines. I don't think we would not get excited if things go well to like keep growing a bricklaying robotics business maybe in year 6, 7. However, we don't think we're going to get stuck there, because I think there's so much opportunity to keep expanding and like add product lines and actually go towards this vision of like have robots built almost or like a big part of an entire house or building, and that's something that's like a multi-decade bet.
I mean, 10% is bricklaying and 90% is just the entire platform, the team, like the company culture, the engineering culture behind it that allows us to build these things. And I see many use cases that we can apply this to.
Mm-hmm. Yeah, okay. So we spoke about the business model, about how you guys started. your marketing department, and a little bit about the robot and bricklaying. If you were starting over again, what would you do? Anything differently?
It's actually hard to answer.
From which angle?
I mean, we're failing all the time. Like that's something. We're building a very complicated piece of technology. Everything we do basically breaks down immediately, and the whole point is you want to like 2 steps forward, 1 step backwards, and like we have these micro failures all the time. And our company basically tries like in the different direction from that. So you're every time you come up with something doesn't work, and yeah, that's the whole strategy. If we redo it again, yeah, if we have all the knowledge that we have right now, you're probably done in a week. But it doesn't work that way. That's not how engineering works. So I think we probably walk the same path more or less.
I don't think there are like on a like meta level. I don't think there's anything we would really do differently. We've taken, for example, I'll mention one thing. Like we once, against better judgment, we're like, let's experiment because we still don't know how much we know with working with an external subcontractor to build a component of our system. When we were doing it, we were like, probably not going to work, but let's see. Like, we're not experts. There are experts that can do some things better. It didn't work out. I would have not done it again, but in a way, it's like it was still a valuable experiment. Like, I still think we learned from it. So, yeah, it's like with the knowledge today, I would definitely
let's not do it.
that.
But
but like, I don't regret trying it.
No, you're well where we are. Any more from you, Mark?
So you think it will be decreasing the cost of production of these robots, or it will be increasing at some point? So like the analogy I can drive here is like, for example, Tesla founder can say, "Oh, we're trying to get the car for, let's say, $20,000 out there in the next 5 years." Yeah, and that's what we're aiming for. I think he's been successful with proving what he promised in the past. How do you think about like driving the cost? Because it's technology ultimately. So there is this deflationary aspect of technology, which would decrease the price in time, really, right, of the piece of tech. How do you?
I think it's a very nonlinear equation in a sense. If you think about payback time, for example, of a robot, you want to make sure it's as cheap as possible, so it pays itself back in like a minimum amount of time, and that's great. But maybe if you spend a little bit more money on it, like you get lots more payback time. Like you can make it a lot sturdier and it will behave better, and maybe you can use it for 5 years instead of 2 years. But the question is that worth it, or is it cheaper to replace parts like sooner, or maybe come up with a new fleet? It's very hard to tell. They're already pretty cheap, and I think in some ways we can go a lot cheaper. And maybe in different parts we actually want to spend a little bit more money because maybe like the swing joint is a little bit flaky. If we spend a little bit more money on it and make it much sturdier, maybe we can create much better walls and operate quicker in a sense and lay down more bricks. So it's very hard to tell. I hope kind of stabilizes, but I'm not sure if you have different opinions on it, but it's hard to...
my answer would basically be, it doesn't matter for us. Like, I do think there's like a fundamental difference with a consumer company like Tesla. We already achieved, like in a way we've already succeeded in that we can build an affordable low-cost machine. It doesn't, like I don't think we can get the cost down by another 60%. I don't think it matters. And if I think about our roadmap in the next 3 years, what I care about more is making sure it becomes more productive, which in some cases might increase or decrease the cost. But in all cases, honestly, like all the examples Sebastian talks about, I think we're talking about 10% differences, not like 50% differences. So in the equation of, say, like payback time, the main driver that we control or that I'd like to spend our time on is the revenue side, the productivity of the machine, and not like the cost to make it. Mm-hmm. And the productivity.
That's also always maintenance and like how easy is it to deal with, and like are there any side costs that you want to minimize?
Yeah, because it can cost, let's say, 50,000, and it can work 24 hours a day for 10 years. Yeah. What's the annual cost of the employee like that?
Yeah.
Very little.
Yeah. So we might learn lessons where we increase the cost and it's still fine. That's. Do
you have any more questions?
No.
Okay, cool. All right, thanks, guys. So that's the end of episode 3. And episode 4, we'll be diving into the destination of Monumental, future predictions.
Thanks, guys.
Thank you. So you're saying there's the building which is designed, and then there's a truck coming to the side. the doors open, there's 25 of them coming out, and then start building piece by
That's kind
piece.
of like, why not?
With any startup, there's always the risk of failure. I'm sure it's crossed your mind maybe once. What if Monumental fails? Will it always be bricklaying that you guys focus on?
No, we definitely don't want to just be a bricklaying company. I think the issue, basically what I consistently hear is that the industry wants this. Everyone is actually very excited about this. But they've mostly been burned by the fact that people have been talking about this for decades now, and it's not happening. It's not good enough, or it's just not happening. I think that's actually like an interesting, like people have been talking about robots taking our jobs since after World War II in every industry, right? It's like from the age of the Jetsons, and it just doesn't happen. That's actually the reality of it, right? And I do think like a lot of people are looking to work at a company with an important mission. So construction initially sounds boring, maybe to some people, but then you explain like, why are we doing this? Why is this important? Why is this important to society? And what we hear during interviews that a lot of people like, I've never thought really deeply about this industry, and suddenly they get excited. And then they get excited when they see what we're doing here, what impact it could make. A lot of people are actually looking for tangible work, tangible results, right? They're like, what am I doing with my life? I'm sitting behind a computer making spreadsheets or PowerPoints. Like in a way, that is something that's fascinating to me. Is like people do want to do, gardening, building things, like physical objects. There is something into the tangible world. So I think if you can combine that, make that sexy again, improve productivity in a way that you can pay them better also, like there's enough money to be made on all sides, including on the people operating it. Like I think that's a very exciting vision to make this kind of like an interesting industry to participate in again if you're young. The name is Monumental. It's like I would love for our robots to be able to build actual monuments that will last maybe way beyond the age of this company, like maybe millennia even. Like that is actually almost the privilege of being in construction. Is you can build things that might survive beyond almost anything else we can do. We have buildings that are older than the oldest writing we have, right? Like that's really unique. And so, I don't know if that should be like, a cathedral, a big building, but something monumental, something on that, like at that level that might survive for centuries or longer. Like that would be my personal like goal.